Good morning, this is your Stat Sensei, Mr. Spensei, and this is a assignment on high pressure situation, and we're going to run a confidence interval. We've already looked at this in the warm-up and also as a hypothesis test, and now we're going to do a confidence interval for a paired T. So let's take a look at the scenario again. More than 100 million adults, that's our population in the United States, have high blood pressure. A study investigates the effect of a new antihypertensive medication on systolic blood pressure. Researchers randomly select, hey, there's our condition, 10 patients, so there's our sample size, diagnosed with high blood pressure and measured their systolic pressure before starting medication. After 8 weeks of taking the new medication, it was measured again. The fact that it was measured, the same person was measured twice, lets me know that this was paired. So that's how I know that this is paired data. Um, the researcher calculated the difference in blood pressure for each patient before minus after. A dot plot of the differences indicated the means of the differences was normally distributed. So that's condition 3, that we are normal. All right, now what they ask us to do in this is not run a hypothesis test. We've already done that. We did that in a previous video if you need to see it. We're going to create a 98% confidence interval for the average drop in systolic blood pressure. So our formula, boy, I'm messing that up. Sorry about that. Our formula is x bar d plus or minus t star sd divided by the square root of n. This is essentially the same formula as what we have for a one sample. For one sample, it'd be x bar plus or minus t star s divided by square root of n. But yes, you have to drop the d's on it. If you don't have it, we're thinking it's one sample, not paired. So we're going to calculate t star, and you can see that I already have it there. And what we did, and you can see it, is second vars inverse t parenthesis, parenthesis 1 minus, they wanted 98, so 0.98, close parenthesis divided by 2, and degrees of freedom. Well, degrees of freedom are going to be my sample size minus 1. So 10 minus 1. And we end up getting 2.8214. And we're positive people, so we're going to always keep this as a positive. Plugging in, because now we can plug in, you can see that we plugged in. Oh, I need to go back just a moment. Let's go ahead and list our data before we plug in. To do that, I entered all this information into StatEdit. So StatEdit, there's all my information. I go to the top of L3, blue 1 minus blue 2. And there's the difference, 150 minus 133, 160 minus 142, etc. And I went into more detail on that in the other video. So now I'm going to go stat calc, one variable statistic, blue 3. And there's my sample mean. There's my sample size, 1.663. And 10 minus 1 happens to be my degrees of freedom. I can go ahead and plug that in. So there's my sample mean of 50. That's my X bar right here. And I should go ahead and not write X bar. I should write this as X bar D. This is T star. And you can see the T star came from just above right here. And this is SD, which is right here. And this is N, which is the number of pairs. All right, so that's all the information. We are going to run a one sample paired T interval. Very important that you use the word paired, but one sample paired T interval, technically for means, but what we're looking for is one sample paired T interval. And I'm going to go ahead and say, hey, stress that word paired. All right. Please remember, confidence intervals are always centered on X bar. Hypothesis tests are centered on a population mean, but we don't know the population mean. So our confidence interval is going to be centered on 15.1 with the lower and upper. And there we go. That's our drawing. Let's go ahead and run this test and get our interval. So stat test, drop down to T interval. Data needs to be highlighted. Our list is an L3, so blue 3. And we need a 0.98 confidence level. So 13.616 to 16.584, with this being my lower bound, and this is being my upper bound. And we're 98% confident that it lies within this interval. It might be as low as this, might be as high as that. So our parameter, let mu d equal the true population mean of the differences. And it's no longer just mean, it's mean of the differences. So make sure you include those phrases, that phrase right there. All right. In systolic blood pressure of patients. Also make sure you have the D for mu D, because it's not just a one sample. Now the conditions we did in the prior video. So if you want to see the conditions, you'll need to go to the hypothesis test. We've already done those. So we're not going to do them twice. So finally, what are we? Well, we are 98% confident the true population mean of the differences, there's that phrase again, in patient blood pressure. And by the way, this is just a restatement. This is just a restatement of the parameter. So this part right here is just a restatement of the parameter, lies within the interval 3.616 to 16.584. And we know that this right here was also given up there. Finally, the meaning. In repeated sampling, we expect this method to capture the true population mean of the differences. Don't want to forget about that word difference, mean of the differences in patient blood pressure. Once again, this right here is a restatement of the parameter 98% of the time. All right, that takes care of the confidence interval. The hypothesis test is in a prior video. I hope this helped. Look forward to seeing you on the next one. Thank you.